something is stirring beneath the tourist island of Santorini. It's another news tremor felt at one of the largest volcanic eruption sites on the island off the coast of Greece after minor earthquakes struck the Greek archipelago, forcing authorities to order the closure of schools. Beneath the sun-drenched cliffs and sapphire waters of Santorini, a hidden force is awakening. A relentless swarm of earthquakes has begun to rattle the island, sending shockwaves of fear through the scientific community. Could this be the precursor to an explosive eruption, one that echoes the catastrophic blast that wiped out the ancient Minoan civilization over 3,600 years ago? The signs are growing more ominous: increased seismic activity, rising magma, and eerie shifts beneath the island. Scientists are now sounding the alarm. This isn't just another tremor. The volcano beneath Santorini, one of the most dangerous in the world, may be on the verge of unleashing its fury once more. How much time do we have before nature strikes again? What could this mean for the thousands of people living in its shadow? Stay with us as we uncover the terrifying truth beneath Santorini before it's too late. Deep beneath the tranquil waters of the Aegean Sea, an ancient and restless force is stirring, a geological drama unfolding near one of Greece's most iconic islands, Santorini. Recent seismic activity in the region has transformed what began as a modest tremor into a full-blown earthquake swarm, catching the attention of the global scientific community and raising urgent questions about the future. On the evening of January 27, a modest magnitude 2.0 earthquake was recorded approximately 20 kilometers northeast of Santorini in an area where small quakes are not uncommon thanks to a natural northeast trending fault line. This isolated tremor might have been dismissed under ordinary circumstances. However, within the span of just a single day, the region experienced the equivalent of nearly 7 years' worth of typical seismic activity. Between January 29 and 30, over 130 earthquakes were detected, signaling a significant departure from the norm. At the heart of this emerging unrest lies Colombo, a submarine volcano located in close proximity to Santorini. Colombo is not a stranger to violence. Its most infamous eruption in 1650 unleashed a deadly explosive force that left a lasting mark on the region. Today's seismic surge is focused on this underwater system, stirring memories of past catastrophes and prompting urgent scientific investigation. Recent seismic data suggest the possibility of volcanic tremors, subtle signs that magma may be on the move. While some of these signals might be attributed to non-magmatic fluid activity, the pattern is enough to raise serious concerns about what might lie beneath the seabed. Imagine the volcanic system as a colossal pressure cooker on the verge of boiling over. Just as heat builds within a sealed pot, raising pressure until the liquid violently erupts, the movement of magma, measured through seismic waves and ground deformation, indicates that immense energy is accumulating beneath the ocean floor. Technical terms such as volcanic tremor and magma movement become the scientific equivalent of steam and pressure gauges in this high-stakes scenario, offering crucial clues to the volcano's next move. The distinction between Colombo and the larger Santorini volcanic complex is a subject of ongoing scientific debate. Some geologists regard Colombo as an independent entity capable of generating its own destructive eruptions, while others consider it part of a broader volcanic system that includes the famous Santorini caldera. The current unrest, however, appears to be concentrated in an underwater chain of 27 volcanic vents situated between 5 and 22 kilometers northeast of Santorini's northeastern shoreline, rather than on the inhabited islands themselves. Historical records remind observers of the immense power held in these volcanic systems. The ancient eruption that formed the modern Santorini caldera over 3,600 years ago reshaped the landscape and forever altered the course of regional history. Now, with renewed seismic activity and the subtle but ominous signs of potential magma movement, scientists are on high alert. Their meticulous research continues as they work to uncover the potential risks lurking beneath the Aegean. Monitoring of seismic waves, ground deformation, and gas emissions is driven by the pressing need to decipher the signals from the depths and predict whether this unrest might culminate in another catastrophic eruption. Colombo, the largest vent within the volcanic system northeast of Santorini, was the source of a catastrophic eruption in 1650, one of the most violent events in recorded Aegean history. The eruption triggered devastating pyroclastic surges and a powerful tsunami, resulting in at least 70 fatalities on Santorini. This explosive event reshaped the underwater landscape, leaving behind a massive 3 km wide caldera and forever marking the region's geological history. Prior to the eruption, historical records suggest that the region experienced intense seismic activity, likely due to the intrusion of magma into the shallow crust beneath Colombo. Though precise records from the time are limited, Written accounts from Santorini residents described frequent earthquakes and an increase in hydrothermal activity. Fishermen and sailors reportedly observed strange disturbances in the water above Colombo, including bubbling, discoloration, and the emission of noxious fumes. These phenomena were likely caused by the release of volcanic gases and the heating of seawater as magma rose closer to the seafloor. The initial explosive phase of the eruption occurred when seawater came into direct contact with ascending magma, triggering a violent phreomagnetic explosion. This interaction resulted in an enormous steam-driven detonation, which blasted apart the seafloor and generated an eruption column that rose several kilometers into the sky. As the eruption intensified, pyroclastic flows, fast-moving currents of superheated gas and volcanic material, raced across the water surface toward Santorini. These surges, moving at speeds exceeding 100 km per hour, 62 miles per hour, incinerated vegetation, destroyed buildings, and suffocated inhabitants caught in their path. In the wake of the catastrophe, land may have been rendered uninhabitable due to contamination of water supplies. Survivor accounts suggest mass evacuations, and historical records indicate significant climatic effects, as volcanic ash and gases released into the atmosphere disrupted weather patterns. Climate records suggest that water disturbances affected agriculture across the eastern Mediterranean, exacerbating food shortages and economic hardship. Colombo itself underwent dramatic morphological changes. The explosion created a large submarine crater approximately 3 kilometers, 1.9 miles, in diameter and 500 meters, 1,640 feet, deep. Today this caldera remains one of the most active geothermal sites in the Aegean, with continuous hydrothermal venting and seismic unrest suggesting that the volcano is far from dormant. Despite remaining relatively quiet in recent centuries, Colombo is far from inactive. Continuous hot degassing from multiple hydrothermal vents near its summit and periodic earthquake swarms serve as reminders of the restless forces beneath. Historical records indicate that previous phases of volcanic unrest have been marked by extended periods of seismic activity, lasting for 9 months between 2006 and 2007, and 6.5 months during 2021, each characterized by hours-long earthquake swarms. Currently, a new seismic swarm appears to be emerging. While less intense on a 24-hour basis than the major 2007 episode, this event is notable for its spatial distribution. Unlike previous swarms concentrated directly beneath Colombo and its chain of vents, the present activity extends beyond the conventional boundaries of the volcanic complex, hinting at a possible tectonic shift in the region. On a global scale, the most significant event within the last 24 hours was a 5.1 magnitude quake, a modest reminder of the planet's ceaseless tectonic energy. Although the activity appears subdued at present, these observations weave together a narrative of Earth's restless inner workings, promising that even the slightest tremor might herald the unfolding of a more dramatic geological story.